Could you hop on the call and just see if it's all right? Everything good? Cool. Sweet. So thank you very much, guys, for coming. And I also see we have Griffin in the call too, so very good. So yeah, I just wanted to do another workshop specifically on Python. Now Python's used pretty heavily in our team, and even in subsystems that don't necessarily put it on their hardware, they do use it for a lot of like supplementary tasks involved. So like, for example, our friend Luke here was working on a project for ADCS and was developing an interface for a web API and was using Python to interact with that website. So Python is used pretty heavily in the team, but this workshop hopefully covers some really good features that you can extend past and bring into school projects or other projects that you end up working on. So today, this is our agenda: the who, what, where, when, why, how of Python. We're going to do a simple hello world program. We're going to talk about virtual environments and packages. That's kind of like the biggest thing I want to take away from today: virtual environments, and really how to run your packages and run your modules like reliably and safely. And we'll kind of learn what that means a little bit. We'll just briefly talk about standard libraries and cool features that are available in Python, as well as just bringing up the different data types that make Python pretty unique. And then I'll do a brief demonstration of how Python is being used on the team, and then provide some additional resources at the end. So moving on to the 5 Ws of Python. So you'll often hear these 4 different descriptions of Python. You'll often hear that it's interpreted. And so what an interpreted programming language is, there's actually a second program that reads your lines of code line by line. And it reads the line of code and then executes the line of code. And this is in contrast to a compiled language, which takes in the entire libraries, headers, and source files that you've written, and then creates one executable that you then run. So Python is an interpreted language. It has the Python interpreter, and that's also why you'll often hear Python is a slow language compared to C++ or Java. That the reason why it's slow is that this secondary program actually has to step by step go through the entire programming script that you've written, and then execute it line by line. So it's also object oriented. So you have all fun stuff like classes, objects, methods, and attributes. And it can contain data and code in the forms of properties and methods. It's also high level, so there's a strong abstraction from the details of the computer. So you're not really worried about memory allocation. You're not really worried about things called like the call stack and pointers and all that. It's all that is kind of taken care of for you. And then it also has dynamic semantics. So in comparison to, let's C++ or Java, where you have to declare a variable in a type, in Python, you can set anything equal to anything, basically. All Python like equal statements or all data types have a root class or root object called object. And so when you transfer between different assignments, you are just updating what that kind of core object looks like. And you can do that dynamically. So you can say x equals 5, but then you can say x equals Jill, and Python isn't going to worry about that, even though you just converted an integer to a string. So you can do a lot of flexible things, but you do have to be careful with that because it can lead to a lot of mistakes as well. So why use Python? So Python, it allows for rapid application development. Pythons are really good at gluing all these different pieces together. So with Python, you can call C++ or C executables. You can call different scripting language scripts. So if you have let's say a Java file, a Ruby file, you can use Python and actually execute all these different scripts as well. Python has an emphasis on readability. It's pretty low syntax, so there's no unnecessarily semicolons, no extra brackets. It's pretty clean and emphasizes readability. And then it has extensive modules and packages that we'll see later on that provide just many different features that we can kind of use off the shelf and not have to write ourselves. So who is Python? I've made some comparison to Java and C++ already. And I think these two languages usually are what people have experience with, either through high school or 143 or whatever. So just doing a quick comparison between Python and Java. So Java is faster and more efficient. As I said, because it is a compiled language, whereas Python is interpreted. However, Python has a simpler, more concise syntax than Java. And I was actually reading a bit of a study, and that showed that I think Python can perform the same function as Java, and I think about 10% less lines of code. And then when you move that to C++, yeah, Python is 5 to 10 shorter than the equivalent C++ code. So yes, it does take longer to actually execute. However, with simple scripts and developing in a design team, writing fewer lines of code means you can develop a whole lot more faster and get a reliable piece of software kind of out and ready in fewer lines of code, which is always good. And then as well, just mentioning the last point with the C++ comparison, Python shines as a glue language. It can take in all of these different functionalities, and you can combine it with components written in C++. So when is Python used? You'll find Python pretty much everywhere. And so that's why I didn't want to just focus what we're doing with Python in the team, but kind of broaden this out, because you'll see Python in website development, task automation, data analysis and machine learning, and data visualization. And so underneath each one of those headings, these are all the different packages and modules that are basically pre-written functions and pre-written classes that you can use within your projects. So where is Python? Python actually comes installed in most Mac operating systems and Linux operating system. Did everyone here get a chance to download Python? Python 3, I hope. Python 2 is pretty old now and we don't really use it. Cool. And then we'll look at commands a little bit later, but the one I really want to emphasize is which Python. You can have multiple versions of Python, and it can be a little confusing exactly what happens when you hit the little play button on top of your Visual Studio Code IDE, or even when you type it in a command line. So which Python specifies exactly which Python interpreter you're using to run your Python modules. So how do I use Python? There's actually two different ways to do it. In your command line, you can actually just type Python or Python 3, and what will happen, your command line interface will change. And instead of having a $sign at the very end, you'll have these three greater than arrows. So this means that you're now in the interactive interpreter. And instead of making like a Python module, you can write Python commands right in front of the interpreter. And so, for example, you can do A equals 5, hit enter, B equals 10, hit enter, and then do C equals A plus B, all in the command line. And you'll have the data stored, and you'll have your outputs shown on the console. Or if you don't want to use the interactive interpreter, you can write a script that ends with a .py and then run it using Python, the name of your script. And we'll look at both of these in the next few slides when we go into more the interaction side. But before that, I just wanted to just briefly touch on Python data types. There's extensive YouTube videos, extensive LinkedIn learning videos that go over all of these. But I just want to make sure that everyone's at least aware of some of the data types available in Python, because data types are kind of what are the backbone of many programming languages. So starting off, we have integers. So these are your basic building blocks. They are representing any whole number. So 3, 300, 200. Next is floating point, anything with a decimal. And then going next into string. So it is any ordered a sequence, and you'll see that there's double quotes as well as single quotes. Python doesn't care. They're the same thing. I know in C and C++ they are slightly different, but Python doesn't care about this. Everything is just a string. Now moving on to lists. So this is just any ordered sequence of objects. And what I alluded to before, all data types are kind of on top of the object class. So each one of these data types can be expressed as an object. And so with a list, you can have a list of int object, a string object, or a float object, or you can have a list of a list or a list of dictionaries. And then these lists of lists, that's how you get into what other languages would call it, like an array or a 2D array. So moving on from lists, we have dictionary. And so this is any key value pair. And so the key is basically what you would look up, or would be perhaps an address or like a column. And then the value is what would be at that address or where you would do the lookup. So for example, we could do a key for name, and then the value would be shown. And then you could do address, and then say Victoria Hall. So these are just so you can map a key onto a value. Or let's say you want to have, for an ACS example, you could have RPM. You want to look up the RPM of your motor, then you can store the value there. Or the temperature of your motor, you can store the temperature there. And so now you're creating almost a data frame that utilizes the dictionary data type. So after that, we have tuples. And I just want to bring everyone's attention to this word here, immutable. So in Python, data types and objects can be either immutable or mutable. And what that means is you can manipulate them. So when it's immutable, when this object is created, so let's say we have a tuple represented by circular brackets of an int, a string, and a float. Once that's created by a function or created by a class, we can't change it. It's immutable. We cannot perform any appendages or removals from this tuple. However, both lists and dictionaries are what we call mutable. You can append to a list. You can pop an item off the list. You can remove a key value pair. You can update the value. You can update the key. So lists, dictionaries, strings, these are all mutable, whereas tuples are immutable. You cannot change them. And so that is very useful when you provide something to like the user of an application and you don't want to let them change anything core to your program. You would provide something immutable, and that's just something that they would use. So then after that, we have sets. And so this is a collection of unique items. I haven't used them too often, but set is just like the mathematical expression. Every item in this curly bracket is unique from one another. And then, of course, we also have our Booleans, so just representation of our true or false. So any questions with data types? I know dictionaries can be kind of confusing, or else they were for me at the beginning, but we'll play around with them in our next slide. So if everybody could open up their command line. Wonderful. And so I just want to pay attention to some useful commands. So starting off, there's which Python 3. So now that's telling me exactly where this Python 3 interpreter is. It's in this user local bin Python. And so what I can do is go into my documents. Okay, and then create just a hello world.py. And if I guess I should talk about Vim. Oh, anyways, you can use an IDE like Visual Studio Code or any text editor. I'm just using a one that's directly in the command line. But in your text editor, to create your hello world, all you need to do is print and then hello world in either single or double quotes, and then save it and leave it. And so all our hello world file looks like is print hello world. So again, Python is a beautifully elegant, if you will, language. There's no main curly brackets. There's no semicolons at the end. There's no std out or whatever. It's super, super simple. And so now to run it, all we have to do is do Python 3 hello world, and we get our hello world message. So that is running it with our scripts, but then we can also do Python 3. And now we've entered the interactive interpreter. So as mentioned before, we typed in Python 3, and now you can see the 3 arrows. And what we can also do is print hello world. And the interpreter runs each command line by line. So it entered, we gave the command print, and sure enough, it did. With the interactive interpreter, you can also store values. So A equals 5, B equals 10, and then you can do A times B, and we get the result 50. So if you're developing a Python project or a module, and you just want to test something out really quick, you want to see the behavior of this one command, you don't have to create a whole new Python module. You can just open up the interpreter and do your easy commands and put it right away. So this really helps with testing and just validating some of the features that you can work on. And then to leave it, I believe it's different for each one of the each computer you have, but I believe it's Control C works. No, Control D. Cool. So that was our hello world. And next, I just want to talk about virtual environments. So this is probably one of the most useful and, in my opinion, one of the coolest features of Python. What virtual environments are they are an enclosed space in which you can house different packages and different Python versions. So I don't know if you guys saw, but when you may have downloaded Python, there's Python 2, Python 3, Python 3.7, 3.8, 3.9.6. So you have many different versions of Python because they keep on adding different features and fixing bugs. And so what virtual environments allow you to do is basically allows for version control for different packages, modules, and different interpreter versions. So in one virtual environment, in this example, you have Python 2.7, and then you have this NumPy version 1.14 and Matplotlib version 2. Whatever. Whereas here you have a virtual environment with Python 3.6, you have pandas and PySpark, and then virtual environment 3, you have an updated Python version as well as pandas and Matplotlib. And so you'll see that this version of pandas is 1.3, whereas this one is version 1.0. So instead of having all of these packages just accessible everywhere on your computer, where there might be conflicts between, let's say, pandas 1.0 and pandas 1.3. For example, Python 3.10 might not be able to work with such an outdated pandas version. So you are required to have pandas 1.3. However, maybe PySpark can only requires pandas 1.0 and must be ran in Python 3.6. So what this virtual environment allows you to do is have version control of your Python interpreters, as well as all your different packages and modules as well. And so when you are working on many projects at the same time, maybe one for course, one for personal, and one for QSET, and they all require different packages, all with different versions, they're not going to conflict with one another. So before moving on to making your own virtual environment, I just want to talk about packages and kind of clear up some vernacular that I'm just throwing out. So a package is a collection of different modules, and a module is a collection of reusable importable code. So a module, you can think of it as just a list of different functions and classes, and then a package would be a collection of those. So for example, we have ATS people here, so I'm just going to pick on you guys again. So you could have an ADCS package. And inside of that package, we could have a reaction wheel module. We could have a magnetometer module, and we could have like a control sequence module, and like a PID controller module. And then the way we would use a package is with an import statement. And then these are used to include all the different packages and all the different modules that are written separately into this main application. So if we had something called satellite.py, we could do import ADCS, and now our satellite has access to all the different modules available within that package. Makes sense, right? We'll look at that just a bit more. So these are the commands to run it. I just included it on the steps or on the slides for now, just for people tuning in later. But we'll do this right now for an example. If everyone could go back to their terminal. Cool. And so the first command that we want to do is Python 3-m venv, which is short for virtual environment. And then we're going to give it a name. So we're going to do Python env, Python prac.env. Hit enter, and nothing happened yet. So the way you work with virtual environments is you basically you've created a safe space, and we've called this safe space Python prac.env. We all love safe spaces. However, we have to make sure that we're in the safe space. So we've created it, but now we have to activate it. We have to put ourselves in the safe space. So what we can do is source, and then in the folder, we have Python prac.env, then activate. Now, if you're on Windows, it won't be bin, it'll be scripts with a capital S. Got that. And then from there, we hit enter, and now we see this Python practice environment at the very end of our one line call. Sorry. Like, what would you say the one line Sean's not prepared or Python Sean?
My fingers have a short
File. Okay, that's the file.
really.
Yeah. Anyways, you see now, if I hit enter a couple times, we have our virtual environment on the other side of our scale. So this means that we're now inside the virtual environment. And so another way we can confirm this is using that which pip or which Python. So now we see we're no longer using the /user/local in Python 3. We're actually using the interpreter located in Python practice environment. So now we actually have multiple versions of Python up and running. But again, just to make sure it's working, we can do our hello world, and it's working just fine. What we can also do, do I want to talk about pip right now? Imports. Yes. Cool. So we have a virtual environment, and I talked about imports and packages. Now let's see if we can utilize some of them. So the way Python handles all its packages, it's in a really smart way. There's something called pip, or, ooh, I should know that. Python, I don't know what it stands for. Package installer for Python. There you go. Anyways, so we can use pip to download packages from the internet and bring them to our local computer. So right now we can do which pip and see that we're using the package installer inside our virtual environment. And then we can actually see with pip list all the different packages that we have available inside our virtual environment. And it's also telling us to update our pip, which we can do. So with the pip list command, it shows all the packages available. So we have the pip package, which is great, and we have the setup tool package. And just to show that it's different or our environment is isolated, we can deactivate our virtual environment. So now we no longer see that Python practice environment at the end, and do pip list again. So you can see on my computer in the basically global Python, I have all of these different packages. Setup tool again, pip again. But in my virtual environment, I didn't have any of those. So this just kind of shows the beauty that the virtual environment has, is that if there was a conflict with our new projects and the packages installed in our local or in our global computer, there will be a conflict and we can handle that. So I'll go back into our virtual environment by hitting source, Python, bin.
Hey, Sean,
Yep.
can you hear me?
Yep.
Your terminal is not showing on the call. Yeah.
Okay. I might have to do this. Okay, is that all right, Griffin?
Yep.
Perfect. Okay, so we're back in our Python virtual environment, and again, I can just show that we have none of our downloaded packages. So what I'm going to do right now is just upgrade pip to the latest version by just using the command that it tells us to do. And then I'm going to install a package called Colorama. And this is just a really fun package that you can use to color your text that get displayed. So it's as simple as pip install and then the package name, and then hitting enter. And so now we can just verify that it got installed, and sure enough, we have Colorama inside of our pip installs. Now to use it, we can go into our hello world and use our import statement. So at the very top, we can do import Colorama. And then if I remember correctly, the way we can use it is for wait. 4.scan, 4.white. And then and 4. Sorry, guys. Red. My bad. Sorry, guys. Oops. Wow, I can't type. From. There we go. Finally got there. So minus the syntax mistakes, let's focus on the actual import statement and the actual use of what we just did. So we have a Python package called Colorama. And in Colorama, we have the module for. And so for just means the foreground and the actual text of the color. And so we can do one of two things. We can import the entire package, or we can just import specific modules. So in this case, we imported just the specific module itself, and then we're able just to use it with the name that it has. So we have import 4 and 4.red, 4.white. 4.red changes the color of the next sequence of text to red, and then the white changes it back to white. And so then if we run it, we see that our text changes colors. So that's all fine and dandy if we want to use external packages. But what happens if we have that satellite.py in that ADCS.py example? So what we can do is create the satellite.py. See, I already have one written. And then we can just do print booting up the satellite. And then run that. Great. So we have a satellite, but now we want to include all our different subsystems. So we want to make an ADCS.py. And in here, we can say printing, booting up the ADCS. And then we can go make sure our ADCS works. Sure enough. And then if we want to use ADCS within satellite, we can do import ADCS, and we will have access to everything that's inside of ADCS. And so you can see the print statement that happened in ADCS first, and then we have our print statement in the satellite. And so now we're getting to a bit of an issue, and we can kind of see what's happening with our import statement. So in our satellite.py, like I said, the Python interpreter goes line by line. So what actually happens, it goes on the first line, it reads import ADCS. And so then it actually basically leaves this file and goes into the ADCS files and then executes everything there. So it does the import and then executes the ADCS. And then we get our print statement, and then it comes back in satellite.py and then executes what's there. And so that's why we have this sequence of booting up the ADCS and booting up the satellite. So that's great and all. However, we don't always want the entire ADCS, the entire comms, the entire whatever subsystem Python scripts running as soon as they're being imported. You want a little bit of control on what's happening. Same with the Colorama example. You don't want all of Colorama just being executed. You want to be able to control when and where you use it. So that is now going to go into something called your main function. So I know I was just saying that Python is absolutely wonderful, that it doesn't have a main function, but we can control it and provide it a main function so that we can control when and where things get executed. So for example, we can do if name equals and then define main and then print okay. So with our little change, we've introduced 3 lines of code, but they're pretty important. So we'll take a look at those. So we've now moved our print statement inside of the Python function. And we're calling this function main. And the way you instantiate a function is just using the define name. And so the next little interesting bit of this script is this if underscore name equals name. And so what this represents is that this name is the name of the file. So every Python file ends with .py gets associated with a name. And when you run the file by itself, so let's say the Python satellite.py, name of that file will be main. But if you use it in an import, so let's say we've imported ADCS, the name of that file isn't actually going to be main. It's going to be ADCS now. So now we're controlling what happens when we run it ADCS by itself, and comparing that to when we run it through an import. So what this says is if name equals main, so if we run ADCS by itself, the name is going to equal to main, and it's going to go to this function called main and then execute the print statement. However, when we import it, the name is going to be ADCS. So this is now false. It's not going to do the main function, so it's going to skip everything entirely. So we'll take a look at that now. So we can do Python ADCS, and we can see that we've now booted up the ADCS just fine by allowing ourselves to just run ADCS as the main file. So in that underscore name equals main, it would be true because the main file is ADCS. However, if we then go back into our satellite, where we're going to import ADCS, so the name of that file is no longer going to be main, it's going to be ADCS. So we shouldn't see anything run from ADCS now. And then we can do Python 3 satellite.py. And sure enough, we have booting up the satellite and no ADCS. However, what can get interesting now is if we have a function called boot up. And then we can say spinning the reaction wheels. So now we've used the same syntax. We've just created a new function called boot up using the define statement. And it's just going to print something else out now. However, we now have access to this function. Oops. Through our satellite. So we've imported our ADCS. And now instead of booting up the ADCS before the satellite, we can boot. We can boot it up afterwards. And so sure enough, same functionality. However, we've controlled and we've essentially just made our own Python package for ADCS. And so we booted up the satellite, and now we're spinning up the reaction wheels through the ADCS system. And so let's just take a look at that again. So big takeaways here. We have an import statement in which we import our Python package, in this case, ADCS. We do what we want to do inside. And then when we want to use the package, we just use the package name and the functions available within that package. And then for testing and development, to separate what's available as a package and what's available by just running the entire script. You can have a main function, which only gets called when you run the package script by itself, or you provide functions which can be used as an import. So that's just a really clean way to separate what's available through testing and development and running by itself, and in contrast to using it as an import. Does anyone have any questions about that? Was anyone able to kind of follow along and get this working on their own system? Nice. Emma, I see your laptop's open. Very good. Davis, questions or anything? Good. Nice. Okay. Cool. And what if we want to import our own work? And so import demonstration, Python and QSET. And so now I just want to briefly talk about kind of the bigger picture of what's going on in the team with Python and some really cool stuff that and how you can use it for our satellite right now. So first point, the OBC, it has to handle task management, interrupts, and make sure that the satellite can run autonomously. And so right now, we're looking into this Python package called Task-O, which essentially allows you to upload tasks to the satellite, and then the satellite will run through periodically its lists of tasks. As well, ADCS at the beginning of the year, these slides are a little outdated now, but they were looking into exploring a version of Python called MicroPython. And then what MicroPython allows you to do is put Python on a small like STM32 chip. So you have the ease of use on of typing with Python and writing code in Python, but then you have the flexibility of putting that on like flight hardware, for example. As well, there's some side projects going on called satellite systems. And so this is a Python interface and a Python package used to control different satellite systems, such as deployers, the communication system, as well as the EPS system for monitoring the battery state of charge. So I'm just going to show a little bit about OBC and how that's being used right now, and how it's being used in our mock sat. So in our QSET. So again, I'm still in the Python practice virtual environment, so I can remove that or deactivate it and leave that space. But then in our mock sat, we also have something called a sat in. So this is a new virtual environment that will be used with different packages as well. But it's the same steps. We can do activate, source, sat, env, bin, activate. And then again, if we do pip list, we see that we do have Colorama, but now we have this iSerial, which is an additional package to communicate through serial devices, such as like an Arduino or an STM32. So what we can do with this is I should be able to just do Python main. Sure. And so right now, this is the mock sat software. I'll kill it. Control C. So we can take a look at it. So with the big, beautiful, fancy text, we're using Colorama to highlight all of that. And essentially what it does is same process that we just went through. It boots up our satellite, boots up our onboard computer, and then sets up some of the satellite systems used. And so we'll take a look at the code and see what is actually going on. But it uses all the same features that we just explored, using the Python packages, using the import statements, and doing things in such a way that we control when things are executed and when things are imported, so we can do the same thing. And then this is the more so the task package that we're using to handle, for example, a radio task, a time task, and just a test dummy task. So based on main. So again, we have our import statements up top. We have Colorama, and we use it the exact same way within our print statements. And we also have our main function as well that executes all the imports. And so I know it's a little messy, but the line I want to emphasize is this one right here. So from source.common.satellite import mocksat. So in our example, we did satellite.py. This import mocksat. There will be a file called mocksat.py, in which we're now including in this main.py. And then this is just some cleanup. So if there's an error that happens or an exception that occurs, a ugly message that says failed. And so then we just do that the same methodology from source.obc task manager, import the task manager, and then we assign that to the mocksat OBC. And so now we've turned on our mocksat, and now we're adding all these different features to it, all with the same philosophy of what we use with the ACS example and the satellite example. And then again, we go into comms, we create a comms device, and then we assign it to the mocksat. And then again, this we're just using again the underscore name equals main, just so we can control exactly how files are being handled and executed. And then we can look at, for example, that source OBC task manager. So again, this is just the task manager file. And then if we take a look at in there, we can see that there's this class called task manager. So if we remember from that main file, we had the from source OBC task manager, import task manager. Now you can essentially think of this entire block of code being able to be used in that mocksat or that satellite.py file. So I won't go into detail on what the task manager does, because to be honest, it's a little over my head still. But just know that that is a Python package that we were able to install using pip. And then we were able to use that package with import statements inside of another file, such as this line of code here. So we've just showed that we can download packages from the internet and use it, such as the Colorama one. We just showed that we can create basically our own packages and use them. And so those two are kind of like the backbone of creating different Python projects. And it's also you can create packages for yourself and then be able to use those across many, many different projects just by using that import statement. So I know that's quite a lot, but just the big takeaways are the pip, imports, and just the access to all the different packages. Any questions? Cool. And standard libraries. So I won't go into the standard libraries in their detail. I just wanted to point out just some really valuable things that the team uses for development. The first one is argparse. And so this is actually used for command line parsing. So you can type commands into your command line with different options and then run your scripts accordingly. RE stands for regular expression tools. Those are very helpful for searching and search and replacement of text. NumPy, this is a really good tool for handling arrays and matrices and creating data frames as well as pandas. They go very much hand in hand. And then logger. So this is logging to files in console. And the Moxa example that we showed actually uses logger to generate all of these. So yeah, so again, these are just really important packages that you will inevitably come across if you haven't already. And so I know we've been talking for an hour and we've covered a really good chunk of virtual environments, data types, of data types and imports. However, Python, there's still so much more to explore, and I highly encourage people taking that next step. So the one is classes. I did mention that Python is an object-oriented program. So you have access to classes, and those allow you to store attributes such as integers, strings, floats, dictionaries, as well as methods. So all these different functions together kind of under one class name. As well, there's errors and exceptions. We saw them just briefly with handling the imports. But errors and exceptions is if anything goes wrong with your code, Python usually raises an error and says, hey, there's a command interrupt or a keyboard interrupt, or I was unable to import, or there seems to be a conflict. It'll raise an error. And as a user, we can actually catch those errors and try to mitigate and handle those errors in Python itself, which is cool. Again, so dunder methods, those are similar to, or those are what we alluded to with the underscore, underscore, name, underscore, underscore. And so those are a really in-depth topic in Python. Every object and every file has what are called dunder methods, which allow you to control very like meta level aspects of the Python interpreter and Python scripts. As well, there's generators and iterators. So we didn't really talk about for loops, while loops, or if statements. But those are good ways to generate sequences of data as well. And there's just there is a lot more to Python that we just don't have time to cover. But just know that this isn't it. And as such, I've included links just for some really good tutorials and videos. LinkedIn Learning, as Queen's students, we all have free access to it, and they have some just tremendous videos and a whole wide collection of videos. So I highly encourage that, as well as the Python Software Foundation. These are the people that make Python and make the updates and have written Python. And so they provide tutorials as well on all these different features available for Python. Cool. Okay, and that is it. Any last questions before we wrap this up? Okay. Griffin, any questions for you? Okay. I'll stop the call now. No worries.